protein misfolding and aggregation is a common hallmark to diverse neurodegenerative diseases. So Alzheimer's disease, Parkinson's disease, Huntington's disease, amyotrophic lateral sclerosis, or Lou Gehrig's disease, as well as prion diseases, are all characterized by the deposition of a protein in bad shape in specific neurons. Okay, and so, as an example, so in Alzheimer's disease, you have two faulty proteins. You have the intracellular tangles composed of aggregated tau and the extracellular plaques composed of A-beta-42. In Parkinson's disease, it's alpha-synuclein that forms, that misfolds and aggregates. Huntington's disease is mutant Huntington, and various proteins in amyotrophic lateral sclerosis. SOD1 was the first one to be discovered. TDP43, which also aggregates in frontotemporal dementia, and protein PRP in prion disease. So different proteins, but all getting in bad shape. And so to the second point of the question, what about protein quality control and how this idea came up? It stems from the following observation. The proteins that aggregate in these different neurodegenerative diseases are actually expressed throughout the life of individuals, right? So take, for example, mutant Huntington. So it's Huntington's disease is peculiar amongst the diverse neurodegenerative diseases because it is only inherited. There's no sporadic form of the disease. You only get the disease from your parents. But we've learned a great deal about neurodegeneration studying these sporadic these genetics or diseases. And in the case of Huntington's disease, it's a very useful example to think about because the mutant protein is there all during the entire life, but the disease only starts late. And this tells us something really very, very important. It tells us that although we have these bad proteins throughout, or potentially harmful proteins throughout our life, the disease only starts late. And the question is, why is this? It's because we have these naturally built-in defense mechanisms that actually normally neutralize these bad proteins that we produce at all times. So we have, chaperones that keep proteins soluble, or we have degradation machineries that remove these bad proteins. And it all works well for decades. But as we age, it looks like the system gets overwhelmed, and this leads to aggregation of these proteins that normally do not accumulate. So then that brings a really simple idea, right? We have defense mechanisms that normally work well. Let's try and boost them to protect from these diseases that occur late in life. So in a way, this idea is analogous, to the immune system, right? We have natural defense, that protects us against viruses. And, we have vaccines that boost these immune defense and speed up, the protection against pathogens. In this case, it's conceptually similar. We want to harness protein quality control, so these natural defense mechanisms of this immune system against misfolded proteins to come up with therapeutic approaches that then could benefit, these diverse neurodegenerative diseases. So we're not going after the disease-causing protein itself, right? We are going after our natural defense mechanisms and try to increase that to protect from these diseases.